So, continuation of 1.6. This is 1.6D as in dog, page number 141. We're going to continue on just for a few more minutes with our composition of functions. So we're going to look at example 7 here. So let me write that down. Okay, so here's the problem. There's our function of f and there's our function of g. And we're trying to find f composite g of x, and I wrote it as this, f of g of x. And so what we're going to do then is just in red we're going to put, instead of f or g of x, we're going to, since they're equal, write 5 over x instead. And that says, what I have in red, that says that now I'm going to go look at my f function, and whenever I see an x, I'm going to put this thing in its place. So I'm going to rewrite that. Let's do this in blue here. So that f of 5 over x actually equals 1 over 5 over x minus 2. So a little hairy, but you guys have done complex fractions before, and you know that in order to solve this bottom, we're going to get a common denominator. In this case, it'll be x. So let's just go ahead and do that, just to remind you. We'll leave the 1 alone. But this will be 5 over x minus 2x over x, giving us 1 over 5 minus 2x. Oops, sorry, this is not 2, this is x. Over x, and then we invert and multiply. This goes away, and that's what we end up with, is x over 5 minus 2x. Alright, so let's erase this, and well, let's put the answer here. X over 5 minus 2x. So I'm going to erase the other blue so we can do the next part. So in this one in the blue, we're just finding the g composite f, so we're just switching them around, giving me this, which gives me g, and instead of f of x, I'm going to replace it with 1 over x minus 2 from up here. Because wherever I see an f of x, I put 1 over x minus 2. So that gives me that. Now I'm going to take my 1 over x minus 2 and plug it in right there. So let's do this in red here. So this is going to be g of 1 over x minus 2, 1 over x minus 2. That's going to equal 5 over this here, 1 over x minus 2. Invert and multiply, and we get 5 times the quantity x minus 2 for our g of x. So notice up here in our f function, x cannot be 2. In our g function, x cannot be 0. Okay? In order to find the domain of f composite g, so I'm going to look at the domain here. Okay, well, since we know that the domain of g cannot have 0 in it, and therefore 0 cannot be in the domain of our f composite g, and since f cannot have a 2 in its domain, we know that no output of g of x can be 2. So when we plug a 2 in here, I mean, you can put a 2 in here, but the problem is when we put it back, when we get it, if this were 2, when we plug it in here, we're going to get a 0 here. So our f of x then would have a 0 in the denominator, which means it would not be in the domain of real numbers. So what we have to do is we have to solve 5 over x for 2, because that is what it cannot be. Okay? So what we do is we set, let's write this out as 5 over x equals 2. Okay, so the reason we're doing this is we're finding out what x is in order to make 5 divided by that equal to 2, because that 2 will then go in here and make that 0. So what we're trying to do is find out, by finding out what x is, what number is not included in the domain here, because that's going to end up making that 0. So when we solve for x, we find out that x equals 5 over 2. So 5 over 2 makes this 0, or this 2, okay, so we find out that our g of x is 2, and then we take that and plug it in here. And when we plug it in here, we get a 0, so therefore we get an undefined number here, so it would be out of the domain. Okay, if that makes sense. So the domain of our F composite G would be, it cannot be 0, like right here, and it cannot be 2. Or, if you want to write it in correct form, negative infinity to 0, but it can't include 0. That unions with 0, again it can include it, 5 halves, but it can't include 5 halves. And then 5 halves, again, can't include it, to positive infinity. So that ends up being the domain that works. And I think that's it. And you do the same thing with the composition of G of F. Okay, let's just look for a minute at the decomposition, decomposing a function as a composition, bottom of page 142. It says in calculus, we often need to recognize how a function can be expressed as the composition of two functions. So what we're doing is we're taking a composition of functions. So in example 8, they take h of x and they say that is equal to 2x minus 3 to the 5th power. Okay, so really what this is actually the composition here. So what we're going to do is write that. So this is you've been looking for this. So up until this point, you've been taking f of g of x, plugging numbers in for g of x, and then taking that answer and plugging it in for f and getting this as an answer. What we're doing now is we're going backwards. We've got the composition here, the answer, and we're trying to find out where it came from. Okay? It's kind of like doing the FOIL method. You know, you've got 2x minus 3 times x plus 2, and you get an answer. Okay? And now we've got this long answer, and that's what we're looking for, and now we want to go back and see where it came from. What two terms did we multiply in order to get our answer? It's the exact same thing of what we're doing with the composition of function. This normally was what we're looking for. Now they're giving it to us and they want us to go back to the beginning to find out where it came from. So what they're saying is h of x is actually the same thing as this. So rather than writing this long thing, they just said, okay, here's the function. Let's go backwards. So how did we get from here, what two numbers did we have to take the composition of, or what two parts do we have to take the composition of in order to get this? And so the easiest way for me, and I don't know if the book goes into it much, yeah, I think it might, is I like to look at it this way. Okay, so if I look at this, and then I find out what I had to do to this, what function I had to do to g of x in order to get this. So I'm going to say that my g of x is 2x minus 3. Okay, so what did I do to the 2x minus 3 to get this? Well, I took it to the 5th power. So if my f of x equals x to the 5th power, then what happens is, well, let's just look at that. Let's say that that's the answer, and let's see if it gives us this. All right, so we have f of g of x. F of, well, my g of x is 2x minus 3. And this says that now I'm going to take my 2x minus 3 and plug it in for x here. So that gives me 2x minus 3. And what am I going to do with it? I'm going to take it to the 5th power, because that's what it says to do to my x. So therefore it works. So my decomposition of my function is are these two answers right here. 2x minus 3 and x to the 5th. So if I take the composition of those two, I'm going to end up getting this right there. Okay, so I just went backwards. This is a little tricky, this part right here. You know, why x to the 5th? Because we have this tendency to say, okay, x to the 5th, 2x minus 3, I'm going to multiply. I'm going to multiply x to the 5th times 2x minus 3. And then I'll get my answer right here. And you won't, because that's not what we're doing. We're decomposing it, not multiplying. So you have to remember, this is a key part right here, is what two functions do we have to take g of x to and then plug in for an x value, like we did here, in order to make this work so that we get my composition here. Okay, these are kind of tricky. There's only one example here, and I don't know that I even have any in the homework, but anyway, it is good for you to at least have a glimpse of what's going on with decomposition of functions, because it is used in calculus. And that's it for section 1.6.